In this video, we are going to keep exploring projections and coordinate systems in ArcGIS Pro, and we're going to do some actual real live reprojecting of our data. In previous videos, we've seen how data can look different when we change our coordinate systems. So I'm going to change this one. This was in WGS 84. Now I'm going to change it to NAD 83 State Plane, Massachusetts, FIPS 2001 meters. Our data looks different. If I zoomed out to the whole thing, you can see that now I'm in kind of cone mode. If I switch back to WGS 84 for the whole planet, now I'm in planet rectangle. Each of these files came to us with these projections. They are right for the file itself. However, there may be times you need a file in a different projection. Working with a certain data model, working with a certain workflow, working with a certain cartography you want to make, doing certain types of analysis. You might need this file in a different coordinate system. And we can do that. That practice is called reprojecting. Reprojecting takes a file, does all the complicated math to it, and converts it into a new file with a new projection. So your original file is safe. Nothing is happening to it. So you can reproject your data as many times as you want. But your new files are going to take on the characteristic of whatever coordinate system you are changing it to. So let's reproject some things and see what's going on here. I'm going to just zoom out to a little, let's just zoom out to the states as a whole. I like the way that looks. I'm going to throw this back to my state plane, Massachusetts, just because I think Massachusetts looks better that way. Let's see, another common, so we've talked a little bit about state plane. We've used that. Each of the states has at least one, often more, state plane systems that are optimized for the look and analysis and cartography and whatnot of the state. So we've looked at that. Another really common coordinate system that we will encounter in GIS work is called UTM, Universal Transverse Mercator. So I want to change this file into the UTM zone, into a UTM zone appropriate for Massachusetts here. And I know that the UTM zone that is really commonly used for New England is UTM zone 19. 19 is a really, kind of, it makes New England kind of look the traditional New England-y. That maybe doesn't make much sense if you're not from New England, but if you're familiar with New England, you'll understand where we're going with this. So I'm going to reproject my Mount Holyoke raster so that it is set for UTM 19, which is common for use throughout New England. I'm going to do that by pulling up the reproject tool. Now, I, again, prefer search here. You can search up in the command search. You can search in the geoprocessing window here. You could go to analysis and go to tools and go to the toolbox and search through that way. However you want to do it is fine with me. I also know that within the Arc toolbox, sometimes it's easier to search for a general term rather than something specific. Like this isn't Google. You can't type out a sentence of what you want and expect it to find a tool for you. So I just know I need to project. And as it turns out, the right tool for projecting, changing a raster from one version to, or from one coordinate system to another, is called Project Raster. I know it's Project Raster because I have raster data. What this is going to allow me to do is take an input raster. Remember, hover over the question mark. If you have any questions about what this tool does, hover over the eyes. If you have any questions about what the line means, click on the question mark if you want the full help document. Don't forget that. I want to project my raster. Well, I got to put in my raster, Mount Holyoke. We're going to call that Mount Holyoke. I'm going to call this UTM 18 so I know what's going on. This is going to my default geodatabase because that's where I want this to go. I am making an informed choice to put this in my default geodatabase. It's the right place for me. Make sure when you're putting your file in there that you're choosing the place you want that file to go. If you're working on a computer that isn't yours, the default geodatabase is not the right place. So once you have your data going to the right place, now we got to choose a coordinate system. So I can choose from the current map. That's kind of boring because it's the same thing. I could convert it into states. I'm not really interested in WGS 84. I want UTM. So I'm going to click select coordinate system, and we're going to see a very overwhelming screen pop up. Everything is hidden right now inside these little drop down arrows. We're going to have to unbury it in a second. There are over 6,000 coordinate systems available inside of ArcGIS Pro. So keeping them all hidden away is the best thing for our health and sanity, that's for sure. Now, I could search UTM, and it's going to clarify things a little bit for me. I'm kind of a fan of the full bore navigation just because it helps me see all the options, but I will certainly make this screen a little bit bigger so I can read them better. So I know that UTM is a projected coordinate system. I know this because it projects data using a transverse Mercator, hence UTM. So I'm going to click down in projected. I got all these options: continental, national, grids, tribal systems. Well, there's UTM in its own little folder. Awesome. Going to go to UTM. I've got now a lot more options. What datum do I want to use? Which system do I want to operate with? For my purposes, and for the purposes of anyone following along with our lab document, I want the UTM from WGS 1984. So I'm going to go to WGS 1984. Which hemisphere are we in here in Massachusetts? Northern or southern? That's right, the northern hemisphere. And then I'm going to scroll down, and I said I was doing UTM zone 8 or 19. Excuse me, can't even remember my numbers. 19, very commonly used throughout New England, as we talked about. So 19, we're going to hit OK. As you can see, it just pops that in here. I should fix who was like, hey, wait a second, he wrote the wrong number in there. Good thing I can change that. UTM 19, UTM 19. I never mess with the geographic transformation because, frankly, I'm not smart enough to mess with the geographic transformation. We're going to leave it as it is. This is the underlying mathematics to shift datums, to shift between complex projections. It's a lot of math involved that we don't have to do. We like that. I'm going to leave the defaults the same size. Nearest neighbor works as a sampling technique for me. I'm going to leave the cell size the same. There is so much going on already with projecting data that I don't want to introduce more error. If I needed to resample or change the cell size, I would do that separately and with a different tool, because I don't want to introduce a bunch more error into my data. People are going to make decisions from what we're doing here. Let's keep it simple. We hit run. It spools for a little bit. What it's going to do is pop out for us a new file. There it is. It took a whole 4 seconds. You'll love to see that. And now we're going to zoom in a bit. We're going to see how different this looks. Well, it doesn't look much different. Let's respect our new file here and change our view of this to the UTM 19. See what that looks like. Okay, it's a little bit tiltier. That's fine. When I say classic New England shape, isn't that the classic New England look? Like, you know, New England, that's what it looks like, UTM 19. Anyway, back to our raster here. So I've got my new raster UTM 19. The original one wasn't touched. It is still in its original spatial reference, State Plane, Massachusetts. This one is new and different. And if we click them on and off, I'm going to flash them back and forth here. Something weird is going along the edges. You can see that, right? Look along the edges of this raster. something interesting is going on. Let's zoom in and see what's happening here. Oh, it's like something's peeking from behind. Let's change the ramp of one of these too so we can see this a little better. Yeah, go with that obnoxious one. It's a little different, right? Oh, well, or maybe it's just because I'm viewing it through UTM 19. Let's see if we can view it through the NAD 83 state plane here. Then it won't be, Maybe I need need a different coordinate system, one that doesn't belong to either of these. Let's go to WGS 84. When you project raster data, because of the nature of how raster data works, cells aligned in a grid, a sheet of data. Small changes or big changes, any changes to projections, to how the data is aligned, to shape, to all these things change the way the data looks. And then changes how the data is used for analysis, and then changes how the data is interpreted, and then changes how the data helps you make decisions. What is right and what is wrong. Taking that into account is an essential part of GIS work. So if I were to ask you the question, okay, what's the elevation of that point right there? About, yeah. Well, it says 229 for my UTM data, but if I click on it from this one, okay, it's still 229. Good. But some of these are overlapping and the data might be different. We have data for some of these and don't have data for others. And we can view this as we scroll across the whole data set. So projecting introduces changes. And understanding when the right projection or what the right projection is for certain operations is part of the GIS learning experience. Now, can we do the same thing to states? Absolutely. Let's project that. Now, notice I'm using just the project tool. Why? Because states is not a raster, it's a vector file. Lots of vector bias. They don't call it project vector. The project tool lets me project a vector, though, data center feature class. States project, love that. I'm going to do the same thing. I'm going to flop it into, because it's currently WGS 1984, I'm going to flop it into this UTM the same way. Notice that really cool, you can pull directly from the layers in the output coordinate system here. That's a really nice trick. I like that a lot in Pro. Gonna hit run on that. Okay, so now I have a projected states file. Let's bring that on top and hide our rasters. I'm going to change this states one to a different color though, because it's hard to see when it's the same color. We'll do the peach and we'll do this nice lavender. There we go. All right, let's start peeking along the edges here. Well, I don't see, let's flip. Those look pretty well aligned. Those look pretty well aligned. Let's go out to California here. Or jagged, roughly drawn San Francisco Bay here. Ooh, interesting. So as we're peeking around for changes here, we'll notice that these things are perfectly aligned. There's no change in the alignment, in the positioning when we're doing vector data, because vector data is far easier computationally to project, to reproject. Vector data is points, lines, and polygons, as we remember. Well, what's a polygon if not a series of lines? And what are lines if not the connection between 2 points? Points, therefore, are a lot easier mathematically to change, so we don't see the distortion in our vector data that we do in raster data. However, we will notice as we scroll west here that we're missing some stuff. Where did it go? This is actually the fault of our coordinate system. If we changed our map to that UTM look, UTM 19, we will notice that our map conveniently cuts off on the edges. It's gone. This is the nature of UTM data. For UTM systems, for UTM projections, the error starts to increase. Well, it is. The error is increasing and keeps going and keeps increasing exponentially away from the center line. And so ARC and other GISs, in an ultimate mode of self-preservation, can't display or won't display past there, because eventually your cells or your pixels would be getting so big and so distorted that they would take over the universe. I'm guessing. I don't know. I've never seen it go that far. We'll talk more about UTM in another video, but for now, you have projected both a raster data and vector data. We've seen that projections cause big impacts for the way that raster data looks, feels, operates with, and decisions are made from. Let's see that flip back and forth one more time. Which is correct? Depends on your point of view. There it is. For vector data, that projection does not introduce any error. These look the same, no matter how many times I flip them back and forth. But our UTM coordinate system and other coordinate systems sometimes might only show you a small slice of the world to protect you from seeing the distortions beyond. Stay safe out there.